Good morning. Today's topic is nitric acid. Nitric acid is an oxide of nitrogen and its formula is HNO3. Now its preparation. How can we prepare nitric acid? Two methods in laboratory method and large scale method of preparation. First, laboratory method. How can we prepare? In lab, on heating KNO3 or NaNO3, that is sodium nitrate or potassium nitrate, and concentrated HNO3, H2SO4, okay, that is KNO3, potassium nitrate or sodium nitrate with concentrated sulfuric acid on heating in glass retort, we can obtain HNO3, that is NaNO3 with H2SO4. With H2SO4, we can obtain NaHSO4 plus HNO3. This is the first method. Next, large scale method of preparation or Ostwald's process. Second method is Ostwald's process. How can we prepare? This is taking place in different steps. First step is catalytic oxidation of ammonia by atmospheric oxygen. Catalytic oxidation, first step. Catalytic oxidation, that is oxidation with ammonia in presence of different catalysts like platinum, rhodium, etc. at about 500 Kelvin and 9 bar pressure. Okay, reaction is as follows: 4NH3, that is ammonia, plus 5O2 oxidation, platinum or rhodium as catalyst at about 500 Kelvin and 9 bar pressure. Reaction is taking place and the product obtained is NO, nitric oxide is obtained with 6H2O. This is the first step. Okay. Now, next, this nitric oxide obtained combines with oxygen and giving nitrogen dioxide. Okay. Second step, this is first step. Second step, to this nitric oxide again reacts with oxygen. Okay, what happens? Nitrogen dioxide is obtained. Okay, this nitrogen dioxide formed dissolves in water and giving HNO3. This is the third step. Nitrogen dioxide with water. On reaction with water giving 2HNO3 plus NO. NO gas is obtained. These are the different steps involved in Ostwald's process. This is the large scale preparation. Okay, and by this process aqueous HNO3 is obtained. Okay, aqueous HNO3 is obtained. Aqueous HNO3, that is nitric acid solution is obtained. It can be concentrated by distillation up to 68%. Up to 68% mass can be obtained by distillation. 98% can be obtained by further concentration by dehydration with concentrated H2SO4. Dehydration with concentrated H2SO4, we can obtain 98% nitric acid. Okay, these are the different methods of preparation. Next, what is the structure of nitric acid? Structure will be like this. Okay, that is in gaseous state, HNO3 exists as a planar structure in gaseous state. Okay, this is the structure of HNO3. This length is 96 pm. Okay, 102 degree angle. Okay, then this length 140.6 pm picometer. Okay, this one 121 pm and the angle is 130 degree. This is the structure of nitric acid. Okay. Now, let us discuss different properties of nitric acid. Properties. What are the different properties? First one, it is a colorless liquid. Okay. And its freezing point is 231.4 Kelvin and its boiling point is 355.6 Kelvin. Okay. Next point, in lab HNO3 can be prepared. It contains 68% HNO3 by mass and its specific gravity is lab HNO3 68% HNO3 and its specific gravity 1.504 is the specific gravity of HNO3. Next, third point. In aqueous solution, HNO3 behaves as a strong acid and it gives hydronium and nitrate ions. Okay, it's a strong acid in aqueous solution and it gives hydronium ion. It behaves as a strong acid and gives hydronium ion H3O plus and nitrate NO3 minus in aqueous solution. It forms like this. Okay. Now, next, fourth point. Concentrated nitric acid is strong oxidizing agent. Concentrated nitric acid is a strong oxidizing agent. Okay. Strong oxidizing agent. And it attacks most metals except noble gases, noble metals like gold and platinum. Except gold and platinum. It is a strong acid, it is a strong oxidizing, concentrated nitric acid is a strong oxidizing agent and it reacts with almost all metals except noble metals like gold and platinum. Okay. Now, let us discuss the oxidation properties. Oxidation properties depending upon oxidation. Depending upon the concentration of the acid and the temperature and the nature of material, that is different metals are used. So, depending upon the nature of the material, different oxidation processes are taking place. Now, let us discuss one by one. So, next important property is oxidation. Okay, so HNO3 are oxidated with different metals depending upon the concentration of the acid, then temperature and nature of material, oxidation, the products obtained are different. Okay, so HNO3 with copper, with dilute HNO3, copper with dilute HNO3 and copper with concentrated HNO3, what happens? First, with dilute HNO3, copper nitrate and NO is obtained, that is nitric oxide is obtained in the first case, dilute HNO3. But copper with concentrated HNO3 gives copper nitrate and nitrogen dioxide. So, the products obtained are different. Next, zinc with dilute HNO3 gives zinc nitrate and N2O4 dinitrogen oxide is obtained. Next, with zinc with concentrated nitric acid, zinc nitrate and nitrogen dioxide are obtained. Okay. Now, next on reaction with chromium and aluminium, what happens? Chromium and aluminium are metals, they form a passive film of oxide on the surface of these metals. That is, formation of a film on oxide coating is obtained on the surface of the metals. Due to this, chromium and aluminium do not dissolve in concentrated nitric acid. They do not react with concentrated nitric acid. Next, what happens? Nitric acid on reaction with non-metals. They react with iodine, carbon, sulfur and phosphorus. Okay. With iodine, nitric acid gives HiO3 and nitrogen dioxide. Okay, this is the reaction. Next, carbon with HNO3 gives carbon dioxide and nitrogen dioxide. Okay, now next, sulfur with HNO3 gives sulfuric acid H2SO4 and nitrogen dioxide. Next, phosphorus with HNO3 gives H3PO4 and nitrogen dioxide. So, these are the different oxidation reactions with HNO3. Next, Next important test, the brown ring test for nitrates. Okay, the compounds containing nitrates, that is this helps to detect the nitrates using nitric acid. Okay, now let us discuss that. So, brown ring test for nitrates. It depends upon the ability of Fe2 plus ion. Okay, ability of Fe2 plus ions. Fe2 plus ions reduce nitrates to nitric oxide. So, nitrates are reduced to nitric oxide, which then reacts with Fe2 plus formed and a brown colored complex is obtained. So, after that we are adding sulfuric acid, okay, H2SO4 is adding and obtain a brown colored complex. If nitrate is there, brown colored complex is obtained, which indicates the presence of nitrates. Now, how can we do the test? First, we are adding dilute FeSO4. Ferrous sulfate is adding. Ferrous sulfate contains Fe2 plus. Okay, Fe2 plus reduces nitrates to nitrogen dioxide. Okay, nitrates present in the solution is reduced to nitric oxide, NO is obtained. Then we are adding concentrated sulfuric acid along the sides of the test tube without shaking the solution along the sides. Okay. So, two layers will be the concentrated sulfuric acid and the solution will be there, and a brown colored ring is obtained at the interface between the solution and H2SO4 layer. Okay, brown ring is obtained at the interface of two layers, that is sulfuric acid layer and solution. Okay, this is due to the formation of a complex. This complex is brown in color, which indicates the presence of nitrate in the solution. Now, the reaction will be NO3 is present, reacts with Fe2 plus, and we are adding sulfuric acid. H plus will be there. So, what happened? Nitric oxide is obtained plus 3Fe3 plus 2H2O. Okay. Now, then what happens? Fe2 plus H2O 6 times. Okay, will be there. This reacts with NO, this nitric oxide, and form a brown colored complex, H2O 5 times NO. The complex will be obtained. Okay, this is brown in color, which represents the presence of nitrate in the solution. Okay. Next, different uses of nitric acid. Uses. First use, manufacture of ammonium nitrate. Manufacture of ammonium nitrate is used in the manufacture of ammonium nitrate for fertilizers, and other nitrates for the use of in explosives. Other nitrates are also prepared for use in explosives and pyrotechnics. Okay. Next, second use, that is used for the preparation of nitroglycerin. Preparing nitroglycerin. Then TNT, trinitrotoluene. TNT. Then and other organic nitro compounds can also used for preparing organic nitro compounds. Okay. Next, third use, used in the pickling of stainless steel. Pickling of stainless steel, then etching of metals, then as an oxidizer in rocket fuels, oxidizer in rocket fuels. These are the important uses of nitric acid. Okay.